Oh, let's see. I would like somebody to define diffusion for us. Holden.
Molecules moving from high pressure to low pressure.
High, I wouldn't use the word pressure. What would be a better word?
Concentration.
Concentration, that's the word. Good.
So movement of molecules to high concentration.
To lower, yeah. And what causes it? Austin.
The moving molecule.
The what?
What was the question?
What causes the diffusion from high to low concentration? Remember that little John Kirk animation that...
Just the random movements of molecules.
That's it. Yeah, so keep that in mind. It's just random motion. Think about this. The probability of all those molecules staying piled up is extremely small. It's not zero. It's not impossible. But just by chance, if they're moving, they're not going to stay piled up. They're going to spread out. Okay? And so that alone will cause them to spread out. No doubt when they're close together, they might bump into each other a little more, but after a while, it's just a matter of random molecular motion. Good. Define osmosis. Willow?
Is it the diffusion of water?
Good. Diffusion of water through what?
Through a
Nice. That's it. Through a semi-permeable membrane. Very good, very good. Osmosis is the diffusion of water. Okay. Oh, and by the way, what does semi-permeable mean? Emily? Yeah. What does permeable mean? Something is permeable to water. What does that mean? Right, exactly. So semi-permeable, some things, maybe water. Some things can, some things can't. It's not completely permeable, okay? I guess everything's semi-permeable, right? Even that doorway. It's not, everything can pass through that doorway. So it's a semi-permeable, this wall is a semi-permeable membrane, right? A lot of things can get through the door, but maybe not everything. Okay? All right. How about, okay, so here's the situation. Purple is water, and red is, say, sugar. Sugar in our syrup, right? Which way is the water going to move across this membrane, and why? Ellie? Where's Ellie? Which way is the water going to move across this membrane, and why? Did you hear what I said about the dots? Purple is water, and red is sugar. Okay. The black, there's, well, they're all purple. The little dots. Yeah, they're all the purple dots. So which way is the water going to move, purple dots, and why? To the left. Very good. Why? Because what?
I don't know.
What'd you say? That's pretty close. Anybody want to adjust that a little bit? Willow?
There's a lower concentration of water.
Right. There's less water over here. And if diffusion is the movement of, if osmosis is the movement of water, the diffusion of water from high to low concentration, well, the water's higher in concentration here. And over here, it's lower. So the water's going to move that way. Very good. Now, let's say that this side here is a cell in your body, for example. Then this cell is in contact with which of these? Isotonic, hypotonic, or hypertonic solution? Eric? Very good. Why? What does hyper mean? Oh, actually, hang on. All right, tell me what hyper means.
Above, like one side has more than the other.
Right, but that's good. But more what?
Water.
Actually, tonic, I guess, doesn't refer to water. It refers to what's in the water. Okay? I guess I'd use hyper, I don't know, something, hydro or aqua, hyperaquatic. But actually, hypertonic means more solute, whatever's dissolved in water. So you want to modify your answer? Because on this side, there is less.
So would it be hypotonic?
So this is actually a hypotonic solution. Everybody see that? So the tonic refers to the solute, in this case sugar, could be salt, right? And so the water is going to go from the hypotonic through to the other side. Because this side is hypertonic compared to this side. All right? So you might want to make note. Let me ask you, which egg experimental group, right? You had two beakers. Which beaker was the hypotonic beaker? Marissa? Which of our two beakers that we tested eggs with was the hypotonic? Syrup. Agreed? Hypo means less than. And yeah, so the syrup was actually the hypertonic. Water was the hypotonic. Okay? So if you want to label this, how about this? If hypertonic is more solute, hypotonic is more water, but also less solute. Okay? So what you need to understand is what happens to cells in a hypertonic versus a hypotonic solution. Okay? So you got to remember the eggs. If you can remember that this was the distilled water, what happened to the cell in the distilled water? Rice. What happened to the eggs in the distilled water? Right. Puffed up with water. Very good. And that's what cells do in a hypotonic solution. It's what plant cells do, like my two little plants back there. If a plant starts to wilt, that's because its cells are running out of water, and the water is what holds the cells up in a plant cell. And as soon as you pour water in there, if they're not too far gone, right, you can rescue a plant that's starting to wilt. Because the roots soak up the water, and the cells, because it's water, it's not salt water, right, it's just pure water, right, tap water. The cells will absorb the water by osmosis and pump back up.